All right, so let me write down a function now. So f of x, and what did they give me? They give me 7 ln x over x squared. Now, by the way, I notice here the x is going to be on an interval from, let's see, 3 to infinity. All right, so what I'm going to do now is just look at it, and I want to make sure that the thing is definitely positive. So looking at it, the 7's positive, x squared's positive. The natural log, when you look at the natural log function, it's negative sometimes, but then it goes like this over here. So, when it becomes 0 at 1, but it's certainly positive over there. So I can definitely say it's positive. All right, that's not a problem. I can also say it's continuous. My concern is it decreasing, and I get a good idea it's decreasing, but I want to make sure you understand that the other two functions that were really kind of simple to look at. But I want to go through this and show you it's decreasing on an interval. And the way I'm going to do that is by taking a derivative. And what do? You square the bottom. Take the bottom to the top. That's going to be x squared times root of the top. So it's going to be 7 x squared times 1 over x, which is 7x, minus, let's see, the top times root of the bottom. Well, the bottom's derivative is 2x. Now times 7 is 14x. And then you get natural log of x. All right, let's take a look at that. I realized x is 3 to infinity, so what I'm going to do is I'm going to divide through by x. Makes it a little bit easier for me. 7 minus 14 ln x. I'm dividing by x, by the way, over x cubed. Now, certainly the bottom is, from 3 to infinity, is always positive. I'm kind of concerned about the top now. So what I want to do is solve for 0. So you get 7 minus 14 ln x equals 0, because it'll change its sign there. And what does it give you? It gives you 7 equals 14 ln x. And then I'd divide by 14, I'd get, 1/2 equals ln x. And that would be what? E to the 1/2. And that would be equal to x. So let me just put this down for you. And let me just check to make sure I said that right. Yep, okay. So what do you get? That's where it produces 0. And someone says, I wonder what e to the 1/2 is. It's certainly below 3. All right, square root of e is definitely below 3. So just take a test point over here. All right, any test point you want, by the way. And I would say a good test point to pick would be, I don't know, e squared. And if you plugged in e squared, right? Maybe I shouldn't have put a plus sign over there. I'm just saying take a test point over there. If you took e squared, which is above e to the 1/2, and you plugged it in here, whoops, sorry about that. And you plugged it in here. By the way, the bottom is always positive. I'm not worried about that. It would be negative. What does it mean? The function's decreasing. So it's decreasing. All right. Now that's something you need to state in exams, by the way, that you got a function that's positive, continuous, decreasing on an interval, by the way. It doesn't have to start at 1. It has to start somewhere and go off to infinity. This is starting at 3. So what I'm going to do now, I'm going to do the integration. And when I do that, I'm going to go from 3 to infinity. I'm going to pull the 7 out. I got ln x over here, x squared dx. All right? Let me get my eraser out. I'm kind of done with this stuff over here. I need the room. That's why I'm erasing it. And I want to see if I can do the integration. And the integration, what you're going to pick is, I guess, maybe integration by parts. Let's take a look at it. So I'm going to try to integrate. Let's write this down. U equals ln x du 1 over x dx. Let's see, you get x to the minus 2 dx would be dv. And then v, well, add 1 to the exponent. That's going to be x to the minus 1 over minus 1, so let's put a minus sign over there. So let's write that down. That's going to be, let's see, minus the natural log of x over x minus the v, that's 1 over x, and then you're going to get the du, which is another 1 over x, so it's 1 over x squared dx. I think I can do that. So minus natural log of x over x. I want to point out that 1 over x squared is really x to the minus 2. And we just did it, right? So it's going to be minus 1 over x, all right? Plus some constant of integration. So I think I'm ready to write this down now. And I'll write down a 7, limit, as a goes to infinity. And what do you get over here? Let's write this down. It's going to be minus the natural log. We don't put the minus on the outside. So I'm just going to write 1 plus ln x. Where am I getting this from over here? I already pulled out the minus 1 over x. Limits of integration are going to go from 3 to a. Let's write that down. Minus 7, limit, a goes to infinity. Wow, 1 plus ln a over a minus 1 plus ln 3 over 3. Well, as a goes to infinity, that first term is going to disappear because a grows faster than the natural log of a. So what am I really left off with? Let's write it down now. You're left off with, minus 7 times that second term, which is going to be 7 times 1 plus ln 3 over 3, right? It's a finite number. What do I know about that? It's certainly a finite number. What do I know? This thing over here converges. All right, look at the key. I want to point out when I'm looking at the key, I'm looking at the key now. I'm looking at this, and I'm looking at this. I'm not looking at the work, by the way. Is it the same thing? Well, let's write this down. What do you get? You certainly get 3 in the bottom. You get a 7 plus 7 ln 3. Is it the same thing? Yeah, we get 7 plus 7 ln 3. Different order, but same thing. What do I know? Again, the series converges. Thank you.